Okay, ladies and gentlemen, this is lesson 8.7, the extended piece. We actually aren't covering the full lesson of 8.7 nor 8.8. That is material that gets covered in Algebra 1 with Mrs. Appleby. So we're just going to do part of this 8.7 that we've been asked to do by the district, and then we'll move into 8.9. Function notation. Function notation. Please pay attention to this cute little cartoon down here. This cartoon will make your life easy, and I thought I had a let's go with the smile face since this is what we want. So this cartoon is going to let you know that function notation is just a fancy way of writing f. So f of x equals y. It is just a fancy way. Come over here and look at the linear function and the linear equation, and please compare them and tell me what is different. Hopefully you're noticing the y-intercepts are still b, so those are still the same. Let me see if I can, let's use a crayon. Let's be fun today. And since we're using red, we'll do red. Okay, so we see slopes. I'm sorry, y-intercepts are the same. So if we look at slope, we have slope and slope. We have x right here, and we have an x right here. So the only thing that is truly different is this. And what did we say? It's just a fancy way of writing y. So f of x is just a fancy way of writing y. No more, no less. Just memorize that. Okay, so ladies and gentlemen, we're going to look at a little bit over the function notation. We remember f of x is just a fancy way of writing y. That will make your life a lot easier, so just keep that in mind. Okay, so this is just saying that sometimes we can use f, g, or sometimes h when we talk about functions. When we write f of x, we could write g of x, we could write h of x. Those are the three common letters that are used. For our level for this year, we're just going to look at the f of x. There's just sometimes you'll find you want to use the other ones, but this year we're just talking functions. And so we're always talking functions. We talk g or h, but just basic functions. So we're just going to use f. So for the instance, the function of y equals x plus 2 can be written in function notation. So function notation is when we use the f of x. And again, you're going to notice the y and the f of x are the only things that change. The equation itself is the same. So basically when you're reading this, when you see the f of x, it's just replacing the y and you just write as f of x. And it just represents the value of the function, at x. So when I write f of 3, all that means is x equals 3. If I have x equals 3, then I know I put 3 in wherever I see an x. So that just means this is the y value when x equals 3. So if we're going to use this function or equation, that f of x equals 10x minus 8, and I tell you x equals 3, then I'm going to rewrite this as f of 3, meaning the value of y when x is 3 equals 10 times 3 minus 8. I'm just plugging in a 3 wherever I saw an x earlier. I'm solving, and I find that f of 3 equals 22. This is my coordinate point. And I totally wrote that backwards, so let me fix that. See, we all make mistakes. X is 3 and y is 22. That is my coordinate point. I made a common mistake right there. Y is 22. X was 3. Okay, so let's try this one. If f of x equals negative 18, that's the same as saying y equals negative 18. So I'm going to plug in negative 18 where I would normally have y, and I'm saying it equals 10x minus 8. Then I follow that through, and I still have negative 18, but I need to get this negative 8 away. So I'm adding an 8 to both sides. When I do that, I get negative 10, because negative 18 plus 8 gives me negative 10. And then I'm left with negative 10 equals 10x. When I divide a 10 by both sides, I end up with negative 1 equals x. My coordinate points, this time I wrote it correctly, x is negative 1, y is negative 18. That's all there is to that. That's my coordinate points. One thing you want to be careful for when you're working with these is this watch out. Don't confuse these parentheses as it means f times x. In this situation, it means f of x, not f times x. So that's one little thing. It's also a common mistake.